Welcome to lesson 4.3, representing decimals in expanded form. As you can see up at the top, I have place values written out. So the ones place, the tenths, the hundredths, and the thousandths place. I also have those written as decimals. So 1, if we wanted to be really particular, it could be 1.0, but we're just going to leave it as 1. 0.1 is the tenths, 0.01 is hundredths, and 0.001 is thousandths. As a fraction, again, we have 1, then we'd have 1 over 10 for tenths, 1 over 100 for hundredths, and 1 over 1,000 for thousandths. Then over here to the side, I have two terms. One is standard notation, and the other is expanded form. Standard notation is just writing a number in its regular form. So for this, it would be, for example, we could do 4 and 714 thousandths. Expanded form is taking this number and writing each individual place as an addition problem to show what each individual place is worth, or what each digit is worth. So one way that we can do is expanded form is with words. So in this case, it would be 4 ones, because 4 is in the ones place, plus 7 tenths, because 7 is in the tenths place, plus 1 hundredth, plus 1 thousandth. Or excuse me, it'd be 4 thousandths plus 4 thousandths. So this is an example of expanded form using words. We can also take the standard notation number and just write it as an addition problem for each place. So we could go 4 plus 7 tenths plus 1 hundredth plus 4 thousandths. Now, if we look at this column with the decimals, we can make this a multiplication. We can use multiplication to show place values. So there's 4 in the ones place, so that'd be 4 times 1 plus 7 times 1 tenth plus 1 times 1 hundredth plus 4 times 1 thousandth. The last example I'm going to show you is similar to this one, but now it's with fractions. So the first one will still be 4 times 1. That will go in parentheses. Then we're going to add 7 times 1 tenth plus 1 times 1 hundredth plus 4 times 1 thousandth. So those are 4 examples of how you can write a number in expanded form. I'm not going to do all 4 examples again for our next number, but for our next number, we're going to use 0 and 639 thousandths. With a 0 in the front, with no whole number, with a 0, we can leave this out or we can put it in. For this example, I'm going to leave it out. So again, I'm only going to do one example for this, and the one that I'm going to choose is, the fraction one. So we'll start with 6 times 1 tenth, because 6 is in the tenths place, and 6 times 1 tenth is 6 tenths. Then we're going to add to that 3 times 1 hundredth plus 9 times 1 thousandth. So the process is exactly the same if you have a 0 in the ones place. If you want, you could choose to do it like you could do 0 times 1, but that's not necessary. Then you would just follow the same other examples as I did with my original 4. For the practice problem, they have some story problems, and the example that I'm going to use is 21. There are 21 kids in the classroom. 1/3 of them rode their bike to school. How many rode their bike? So this is a fraction of problem. So we have 21 kids. 1/3 of them rode bikes to school. 1/3 of them rode bikes. So remember, there's 2 ways that we can go think about doing these problems. We could actually draw a picture. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's 21 all divided into the groups of 3, which is 1, 2, 3, 4, 5, 6, 7. So that means 7 students rode bikes. And remember, whenever you have a fraction with a 1 for a numerator, it is called a unit fraction. When you have a unit fraction and you want to find the fraction of that problem, you can just do the division problem. So you could have done 21 divided by 3, and that equals 7. In addition, you could also write that as a fraction, because all fractions are division problems. So 21 divided by 3, it equals 21/3, or it also equals 7. Hope this video was helpful for you, and I hope you're able to watch the next video as well.